Excellent. So we'll take the notes here again. Over the page, there are two Cartesian planes there for you to use. So our first one is 2x plus 3y equals 6. Now we should be able to look at it and identify this is general form. We have ax plus by equals c. All right. Now the first thing we're going to do for general form, what we have to do is we have to identify the x-intercept and then the y-intercept. I want to recall we said the y-intercept occurs when the x value is 0, okay? So that's like a property of all functions on the Cartesian plane. Whenever it crosses the y-axis, the x value has to be 0. So y-intercept occurs when x is 0. That's a property of anything that you sketch on the Cartesian plane. Okay, not just lines, any function. So what we're going to do is we're going to go, okay, x is 0. If I put x is 0 into this equation, I'm going to have 2 times 0, that's 0. I have 3y equals 6. And if 3y equals 6, I can solve for y. I'm going to divide both sides by 3. All right, if I divide both sides by 3, 3 at the top, 3 at the bottom will cancel. On the left-hand side, we'll have y. And on the right-hand side, 6 divided by 3 is 2. So the y-intercept of this equation is 2. That's our y-intercept. All right. Now, the y-intercept occurs when x is 0. What about the x-intercept? The x-intercept is going to be where it crosses the x-axis, somewhere along here. And we know that when it crosses the x-axis, the y value is going to be 0. All right? Everywhere along this line, the y value is 0. So we'll write that out as well. The x-int occurs, I call them the yint and the zint, occurs when y is 0. All right? So if I put y is 0 into this equation, 2x equals 6. Divide both sides by 2. X equals 3. Now perhaps one assumption I'm making is about this algebra, the link from this step to this step. If that's an issue, please speak to me. But I think we should be all right with that. So I have the x-intercept is positive 3. So I've established the y-intercept, I've established the x-intercept, and then all we do is draw a line straight through them. Now with your lines, that's not a graph of a line, okay? A graph of a line should cover most of the Cartesian plane that you have, and you need arrows at both ends indicating that it travels to infinity and beyond. Okay, so that's our first line. So just to recap, we put in when y is 0, we get the, when x is 0, we get the y-intercept. When y is 0, we get the x-intercept. We plot both of those and draw a line through them. Okay, let's do it for the next one. First, we'll find the y-intercept. All right, so y-intercept when x is 0. So we can write it like this. When x is 0, we have minus 4y equals minus 8. So I'm going to divide both sides by negative 4. Negative 4 so that I get rid of the negative, and 4 so that I get rid of the 4. So we have y is minus 8 divided by minus 4. We'll have positive 2. The y-intercept is 2. The x-intercept will occur when y is 0. We'll have 2x. That's right, we'll write it up properly. When y is 0. Now, if ever you can't read anything, just ask. That says when. When y is 0, 2x is minus 8. We'll divide both sides by a positive 2. Minus 8 divided by 2 gives us x is minus 4. So the x-intercept is -4, the y-intercept is 2. We've got both points, and we draw a line straight through both of them, arrows indicating that it's travelling on. Now I've sketched 2 lines here. Can anyone tell me the coordinate where these lines intersect? Where do they intersect with one another?
0.
2. Yeah, the y value is 2. Yep.
And 0.
And x is 0. So they intersect at 0, 2. X is 0, y is 2. Very good. All right, so that's graphing lines in general form. That's enough to now answer question 2 and 4. And that's all that we'll cover today, because the next exercise has a fair bit to it, which we can have a look at tomorrow.